So let's talk about prisms and cylinders. Okay, so why do they call this a base up here? It's the top, and this is the bottom. This is called a lateral face. Why do they call it a lateral face? Okay, like we have latitude and longitude, right? Okay, so that's a lateral face, therefore that's a lateral edge. What makes this the altitude? It shows how high it goes. It also makes a 90-degree angle, and that's why we call this a right hexagonal prism. Okay, so with that being said, let's talk about the lateral area. So the lateral area is only the area, let's change that, only the area of the sides. I would not include the top or the bottom bases. So if we're talking lateral area, let me change all my colors. I would say that capital L is equal to, well, just to find this one rectangle right here, wouldn't we say that that would be H times A, and then H times B, and H times C, and H times D, plus H times E, plus H times F, right? I would be adding each one of these rectangles, right? Isn't that how you find the area of each one of these? Height times A, height times B, height times C, height times D, height times E, and height times F. Or I could say height times all of them added together.
But are you multiplying by height?
Yes. You could also do it that way because they're all the same size, but they're not always the same size. But this one they are because it didn't say it was regular though. If it said it was a regular hexagonal prism, then you would know that each one of those sides is the same and you would just multiply by 6. You're right. Okay. Or we could also say, what would I call this if I were to add all of these up? Not the base.
Height.
The perimeter. Wouldn't it? If this was A, and this was B, and this was C, D, E, F, didn't I go all the way around the figure? So isn't it just perimeter times the height? All the way around, and then multiply it by how tall it is. That's easier, right? Yeah, it's technically what I'm doing with all of each one of them. So let's talk about surface area. We talk about surface area as being T. Can anybody tell me why you think we would talk about it as being T? James? No? Any ideas? Why would we call it T if it starts with an S? Total. Total surface area means the lateral area plus 2 bases. Why am I going to use a big B for base?
2 bases.
But that's not why we use the big B though. Pedro? Because of a little b. If I'm trying to find a base, isn't that base times height? So little b is a side, big B is the actual base. Yes. Yes. The area of the base. So if I had the lateral area, here let's change the color on this, and made it that base plus this base. You know, I didn't say, what is this called? You guys know what this is called? When you take a figure like this and you open it up so you can see it flat? It's called a net. Everybody understands that this is the same as this, right? Okay. All right, let's move on. So find the lateral area of the regular hexagonal prism. There's a few things that we need to pick out of this. We need the lateral area. So lateral equals perimeter times height. Of a regular hexagonal prism. What does it mean to be regular? They're all the same. And hexagonal? 6 sides. Now, personally, I like to draw pictures. So I would say that my lateral height is, each side's the same, right? So aren't there 6 of them? And what's the base of one of these sides? Let's pick a side. But that's not the base. 5. And what's the height? 12. So isn't this 6 times 5 times 12? I got 6 because there are 6 sides. Because of the side is a 5 by 12. So it's 6 times this area right here. That is technically the formula, but you know how I feel about formulas. Yes. Yes. But if you wanted to, you could have said, well, to go around this regular hexagon, wouldn't I just go 5, 10, 15, 20, 25, 30? Could have. Right? 30 and then multiplied by 12, the same thing. But isn't this also 30 times 12? Which is 360 centimeters squared. Questions? Pretty easy so far. Let's move on. Find the surface area of the square prism. So I need the total, which equals the lateral plus 2 bases. I'm going to draw a picture for my lateral. Let's assign some numbers here. What's the base of the side? Well, if I were putting it up on its side, yeah, 12 times 6. And my base, 6 and 6. So that equals 72. But how many of these do I have? No, there's 4 of them. So I have 4, 12 times 6, plus 2, 6 times 6, equals
5.
Oh, why did I put 2? Thank you. There's 4 of them. 4 sides. So this is going to equal 360 centimeters squared. Just by coincidence, it's the same. Questions? Pretty straightforward. Always. May I go? Okay, write these down. Okay. Yes. No, they're not the same thing, but they can be. Right? An axis can be an altitude, but is every altitude an axis? No. Just like all thumbs are fingers, but not all fingers are thumbs? Well, you all understand it? Okay. All right, so let's talk about this. It's the same type of theory. Lateral area just means all the way around it on the side. And surface area is the total area. So lateral area equals, okay, what do we call a perimeter for a circle? A circumference times the height. What do I normally give for a formula of circumference? Pi times. No, see, you guys always get this mixed up. So this is why I use pi times diameter. But isn't a diameter equal to 2 radii? That's where they get this. I like to equate this to like a toilet paper roll. Why is that always so funny to everybody? Doesn't this look like a toilet paper roll? When you go to a toilet paper roll and you unroll it, doesn't it look like that? It's a long rectangle. What do you mean no? You guys, that's where the toilet paper roll goes on, right there. It's on its side.
Oh, it's the...
And if you unroll it, it would look like this. Here, let me give you another visual.
And then her fist is...
Right? When you open it up, it looks like that. Guys, yes, have an imagination. Okay, so isn't this, please be quiet, isn't this the circumference around this?
Yeah.
So when I open it up, isn't this the circumference right here? Okay. All right, so the formula for this would be 2 pi r times however high it is. And the total surface area would be the lateral height plus 2 bases. So I know what the lateral height is. It's 2 pi r times the height, and the 2 bases are circles, right? And circles, to find the area of a circle, you need pi r squared. So technically, you could do all of the problems without any new formulas, just using what we already know.
Ooh, the second formula, 2 pi r times pi squared. That one, that's the formula for yourself.
Yeah.
For every single problem.
Yeah.
Whoa, I like to memorize them.
Okay? Ready? Okay, so let's practice this. Let's find the total surface area of this cylinder. So total surface area is lateral plus 2 bases. My lateral is the toilet paper roll unrolled plus 2 bases. What did I say this side of it is? The circumference. And all we need from this piece is the radius. So let's fill in the blanks. Do I know the circumference of this cylinder?
Yes.
I do. The circumference of this cylinder is pi times the diameter. What's the diameter? 28. And what's the height? 18. Plus 2 times, what's the radius? 14. So 28 pi times 18 plus 2 pi radius squared, and I know my radius is 14. And if I were to put all of that in a calculator, I would get about 2,814 and 9/10 feet squared.
That was cool.
Question? Yeah, let you guys finish writing that down.
Cool.
All right, let's look at our last example. Find the radius of the base of a right cylinder if the surface area is 528 pi square feet and the height is 10 feet. You just have to plug things in. So let's talk about what we've got. We've got our right cylinder. Cylinder, it's a circle. It's a circular object. Okay, I don't even need to draw the circle. I can just draw the net, right? So I'm going to say I know my total surface area of a cylinder is my lateral area plus 2 bases. Correct?
Yes.
This is circumference and this is radius. Let's see what they gave us. Find the radius, okay, so we're looking for R, of the base of the right cylinder if the surface area is 528 pi, so this is 528 pi, and the height is 10. Okay, they're telling us the height is 10. It doesn't, but we know the circumference is pi times diameter, but we can also write diameter as 2 radii. So now I only have one unknown, right? So the area, the lateral area of this shape right here is 10 times 2 pi r, right? So if I write 10 times 2 pi r plus 2, and the area of a circle is pi r squared. Let's just make it look a little bit prettier. 528 pi equals 20 pi r plus 2 pi r squared. Anybody see how we could simplify this?
You can take away the time, between pi,
and something else. You could also take away the 2. So couldn't I divide everything by 2 pi? I can. So when I divide everything by pi, or 2 pi, these both go away. The 2 goes away and leaves me a 10. The pi goes away. This pi goes away. And what am I left with when I take 2 from 528? 264. So let's rewrite this. 264 equals,
10r plus.
ooh, I forgot my r in here. That would have been bad. (10r) plus r squared. How do I solve that?
Subtract no, square root. 4. Can you square root it?
Duh.
And I get 0 equals, let's put it in the order that it needs to be. What do I put?
R squared plus 10r
minus 264. And this isn't fun. You could use quadratic formula, or you could use an x. What two numbers, when I multiply, makes negative 264, but when I add, makes 10. Or Mrs. Mahler could just tell you 22 and 12. One of them is going to be negative. Which one is it? The 12. So this would be R and 22 and 12, and the 12 is negative and the 22 is positive. What do we do with that? Set them both up to 0. So R plus 22 equals 0, or R minus 12 equals 0. R equals negative 22, or R equals 12. Which one is it going to be? Has to be 12. Why, Jane? Because it's positive. And we're done.
Third time.